Alright, in this video I'm going to be talking about methods that we use in order to simplify rational expressions. And what a rational expression is it's just a fraction that's going to have a polynomial on the top and a polynomial on the bottom. And that's all it is. So let's take a look at some of these and see what we can do to make them easier to look at. So let's say I've got x squared minus 64 over 5 times 3x plus 24. So the main tool that you have in your toolbox in order to simplify these rational expressions is being able to factor the things that you see on the top and the bottom. So the expression on the top, x squared minus 64, factors as a pair of conjugates, x plus 8 and x minus 8, because it is a difference of two squares. And on the bottom, I notice inside the parentheses group here, I've got a common multiple of 3. So I can factor that out. And what I get is 3 times 5 times x plus 8, which is going to give me x plus 8 times x minus 8 on the top, divided by 15 times x plus 8. And now, since we got everything completely factored, now it's time to find things that cancel. And this is my favorite part. So we've got an x plus 8 on the top and 1 on the bottom, so they cancel out. And then what I'm left with is an x minus 8 on the top and a 15 on the bottom. So since we don't have anything else to factor and everything is combined, this is going to be our final answer. Let's say that we had x cubed plus 27 on the top, and on the bottom we had x squared plus x minus 6. So at the top here we have a sum of cubes, so that's going to factor in this way. So if we have a cubed plus b cubed, this factors as a plus b times a squared minus ab plus b squared. So in this case, a is equal to x and b is equal to 3, because 3 cubed gives me 27 and x cubed just gives me the x cubed. So on the top here, I'm going to have x plus 3 times x squared minus 3x plus 9. And on the bottom, this one factors into x minus. And on the bottom, this one factors as x minus 2 times x plus 3. Now I can see that I got an x plus 3 on the top and the bottom, so I can get rid of them. And then I've got an x squared minus 3x plus 9 on the top and an x minus 2 on the bottom. So I can't break down the numerator into any other factors, so this is going to be our final answer. Okay, so let's say I had x squared minus 4 over x to the 4th minus 2x squared minus 8 multiplied by x squared plus 2 divided by x squared. Okay, so when you're combining fractions like that, what you're going to want to do is you want to break it down into factors first. So if I take a look at the first fraction here, I can rewrite this as x plus 2 times x minus 2, because on the top we got a difference of two squares and that factors as conjugates. And on the bottom I have an equation of a quadratic type. So I have a u squared minus 2u minus 8, where u is equal to x squared. And then this quadratic type equation factors into u minus 4 times u minus 2. And if I substitute x squared back in for u, I end up getting this on the bottom. So I've got x squared minus 4. Excuse me, this is a plus 2. Because when they multiply together, I get a negative 8. So I got x squared minus 4 times x squared plus 2. And then again, I can factor out the x squared minus 4 as a pair of conjugates. So I have x plus 2 times x minus 2 divided by x plus 2 times x minus 2 times x squared plus 2. And I'm going to multiply that by x squared plus 2 divided by x squared. So to multiply these two fractions, all I got to do is multiply straight across. So what I'm going to end up with is x squared plus 2 times x plus 2 times x minus 2 on the top, and on the bottom I've got x squared times x plus 2 times x minus 2 times x squared plus 2. Okay, now that everything's completely factored, I get to look for things to cancel. So I've got an x squared plus 2 on top and bottom, I've got an x plus 2 on top and bottom, and I've got an x minus 2 on top and bottom. So a lot of things end up canceling here. And then what this gives me is a final answer of 1 over x squared. So let's say I had 4x minus 6 divided by x minus 1 squared, and that's divided by 2x squared minus 3x over x squared plus 2x minus 3. So the first thing that I'm going to do is factor out each of the terms on the two fractions. So on the top of the first fraction, I've got a common multiple of 2 that I can pull out. So I'm going to go 2, and then when I do that, this factors as 2x minus 3. And that's still over x minus 1 squared. And then I'm going to flip the fractions and multiply, because that's what I can do when I have dividing fractions. So the bottom, this is going to end up as x squared plus 2x minus 3 over 2x squared minus 3x, because we're multiplying by the reciprocal. And so now I'm going to factor out the terms on the second fraction. So I've got 2 times 2x minus 3 divided by x minus 1 squared times, and the top part, the numerator of the second fraction, factors as x plus 3 times x minus 1. And the bottom, I can take out an x here, and then I'm left with 2x minus 3. And then to multiply, you just multiply straight across, top times top and bottom times bottom. So I get 2 times 2x minus 3 times x plus 3 times x minus 1 on the top. And on the bottom, I end up with an x times a 2x minus 3 times a x minus 1 squared. Okay, now that everything's completely factored, I can start canceling. So I've got a 2x minus 3 on top and bottom, and I've got an x minus 1 on top and bottom. So once I'm done canceling, I get a final answer of 2 times x plus 3 over x times x minus 1. Okay, so let's say that I had 1 over x minus 1 plus 1 minus x divided by x squared plus x plus 1. Alright, so the first thing I want to do is factor this stuff out. And turns out the first fraction, both of these fractions are completely factored already, so I can go straight into finding the common denominator. And so my common denominator is produced whenever I multiply the two denominators together. So I've got x minus 1 times x squared plus x plus 1. And then I do cross multiplication to find the terms on the top. So first I've got 1 times x squared plus x plus 1, and that just gives me x squared plus x plus 1. And then I'm adding it to x minus 1 times 1 minus x. So I got x minus 1 times 1 minus x on the top. And then the next step for me is I'm going to FOIL this part out on the right and then start combining the like terms that end up on the numerator. So when I do that, I end up with x squared plus x plus 1. When I go to FOIL, I got a x times 1, which gives me a plus x. X times a negative x, which gives me a minus x squared. I've got a negative 1 times 1, which gives me a minus 1. And then a minus 1 times a minus x, which gives me a plus x. And the denominator stays the same because it's completely factored already. Now I can start combining like terms on the top. So I've got an x squared and a minus x squared, and that's going to cancel to give me 0. And I've also got a 1 minus a 1. Of course, that also cancels to give me 0. And so I've got 3 x's on the top that I add together. So I got 3x. And the bottom is already completely factored. So this is as simple as this fraction is going to get. So this is my answer. Alright, this is the last one I'm going to be doing on this topic. So let's say I've got 3x over x minus 2 minus, I'll do x plus 2, minus 4x squared minus 5 divided by 2x squared plus 3x minus 2. Okay, so the first thing that I'm going to do is see what I can factor out of both of these fractions. And so I've got a quadratic term on the bottom of the second fraction that does factor. So when I factor the second denominator out, I end up with a 2x plus 2, or I got a 2x minus 1 times an x plus 2 on the bottom. That's how the bottom factors. Okay, so to find the common denominator, I got to make both of these denominators the same. And I notice that I got a common factor of x plus 2 in the denominators. So in order to convert the first fraction into a common denominator, all I got to do is multiply top and bottom by 2x minus 1. So I end up with 3x times 2x minus 1 minus 4x squared minus 5 divided by 2x minus 1 times x plus 2. And then now I go ahead and distribute the negative sign, and I distribute the 3x across, and then I combine like terms in the numerator. So this is going to give me a 6x squared minus a 3x minus a 4x squared plus a 5 over 2x minus 1 times x plus 2. So the 6x squared minus 4x squared gives me a 2x squared. Oh, that's the wrong color. So that's going to give me a 2x squared on the top. Then I'm going to minus 3x. And then the plus 5 stays the same. And all this is over 2x minus 1, x plus 2. So since the quadratic on the top does not factor in anything, this is what the simplified version looks like, and this is our final answer. So I hope this video was helpful about how to simplify rational expressions. It's a very useful skill that's going to help you out with more complicated calculations later on down the line in your math courses. So thanks very much for watching, and I'll see you all for the next video.